Welcome back, and now we're going to look at something that I said, check it out earlier on in our first segment, mechanical energy. Let's see what it is. Mechanical energy is the sum of gravitational potential energy and kinetic energy of an object. Okay, so you can, from this you can quickly see that mechanical energy then is equal to EP plus EK. That's what that statement is saying. If you add the two, you get the mechanical energy of the object. The principle of conservation of mechanical energy, so we have got a principle that states that mechanical energy is conserved. And what does the principle say? It says mechanical energy in an isolated system is conserved. It says the sum of gravitational potential energy and kinetic energy in an isolated system remains the same. So in other words, mechanical energy in an isolated system remains the same. EP plus EK at one point would be equal to EP plus EK at another point for the same object in an isolated system or in a closed system. This means that if we're looking at things that are swinging, hanging somewhere, we can say that their mechanical energy at the bottom, which is EP plus EK at the bottom, should be equal to their mechanical energy at the top, which is EP plus EK at the top. That's what it means, okay? Now let's have a look at this example here to check and see how we make use of this principle and also to calculate these energies. A hammer of mass 3 kilograms is allowed to fall freely from a height of 30 meters. Calculate the total mechanical energy of the hammer. Now, if this is falling freely, if that represents the hammer, it's falling up to hitting the ground there. At that point where it is allowed to fall freely, at that point before it starts moving, we know V is equal to 0 there. Okay, so it will mean that EK at that point is equal to 0. All right, so if I am to find the total mechanical energy at that point, I mean of the hammer, I would say that mechanical energy equals EP plus EK, because that is what mechanical energy is. So this will be equal to mass times gravitational acceleration times height plus half mv squared of the hammer. The hammer's mass is 3 times acceleration due to gravity is 9.8 times the height. Okay, it is falling at the height from the height of 30 meters. Okay, plus, so this is this is EP, plus half m is 3 times, it's not moving at that moment there. Okay, so V will be 0. So all its mechanical energy is given by the potential energy there. So that will be 3 times 9.8 times 30, and that gives us 882 joules. That is the total mechanical energy of this hammer, this system, this object in this system. Okay, so 882 joules. Now we are told, calculate the kinetic energy of the hammer at a height of 20 meters above the surface. Now this hammer is now at some point there above the surface, and this point is 20 meters above the ground. At that point, it has got both EP and EK. None of them is 0, but they should give us ME. Okay, so because I've got height, I can calculate for the EP of the hammer at that point. So I would say that the mass times G times height plus EK should be equal to total mechanical energy, which doesn't change. We have found it here to be 882, so I can say 882 there. Therefore, EK equals 882 minus, what is this one? What is EP at 20 meters above the ground? It will be 3 times 9.8 times 20. And what is that? Okay, let's work it out quickly. So you've got 3 times 9.8 times 20. What is the answer? That is 588. So this is 882 minus 588. That gives us 294 joules. So EK at 20 meters above the ground for this hammer is 294 joules. Okay, so you can actually do that down here where there is space. I should have used this space here. Now, calculate the speed at which the hammer is moving at the height of 20 meters per second. Now that we have EK at that height, we can calculate the speed at which that the hammer is moving. Okay, how do we do that? From EK equals half mv squared, we can calculate for V. EK is 294, so 294 equals half times 3 times V squared. Okay, so this is 1,5, so V squared equals 294 divided by 1,5. Okay, so 294 divided by 1,5, it's 196. So V equals the square root of 196. Okay, so let's find that. 196 square root of 196, that is 14 meters per second. The hammer is moving at that velocity at the height of 20 meters above the ground. Let's meet in the next section.